Okay, hello everyone. I hope all of you are doing good. So let us talk about our next topic, which is the deflection of beams. I will just cruise through the derivation and then we can start some problems. So we are talking about the deflection of beams, right? So what our objective is that we have a beam and we really want to have an idea of how much that beam deflects. So please remember that deflection, of course, at every point for this beam is going to be different, right? And we really want to have some sort of an expression that can give me the deflection at every point. So let us go through the derivation first. What I will say is that the deflection is V, which is equal to the function of X. So you can see that as I keep going towards right, the deflection at every point for this beam is different. Now, please remember that this is highly exaggerated. In a physical world, you're not going to see this beam deflect this much. This is just ridiculous. So in a physical world, you are looking at millimeters or probably inches of deflection for big structures. You're not going to see something like that. So if the deflection is a function of X, then I will say that dV by dx is equal to the slope tan of theta. Now let's look at this derivation. This is deflection. This is X. X means the position on a beam. This is my beam that is bent. You can see this little line that I have drawn exactly here. This is my neutral axis. You can see that I have drawn an arrow from the neutral axis. The neutral axis is the fiber that doesn't bend, right? I mean, it doesn't have any stress or strain. So this is my neutral fiber. Please focus here. Now, C is the maximum distance from the neutral fiber. V is the deflection. So please remember, the deflection is positive as I go upward. In this derivation, what I will say is, I will say that strain in the X direction, please, these are derivations, you know, so I will just go over it, is equal to delta X prime minus delta X over delta X. That is change in length over original length. So you can see that for any fiber like Y, delta X prime is the change in length along the X direction, and minus delta X is the original length of the fiber, which is actually the neutral fiber, divided by the original length, change in length over original length. All you have to do is, instead of delta X prime, substitute rho minus Y delta theta, because delta theta is this one and S is equal to R theta, minus rho delta theta divided by the same fellow, and I get epsilon X equal to negative Y over rho. Now I just cruised over it, and just to explain, rho is the radius of curvature, Y is the distance from the neutral axis. Now there is just one thing that I want you to remember, and that is that the slope tan theta is nearly equal to theta is equal to dV by dx. Now this is what I really want you to remember. These are the 4-5 expressions. Number one, the deflection, and I really want your attention now. Deflection is equal to function of X, agreed? Then tan of theta, which is the slope, which is nearly equal to theta when the angles are small, is equal to dV by dx. Second formula. Number three, and this is what should be given to you in an exam setting, right? Number three, moment bracket X is equal to EI d square V over dx square. What is V? Deflection. Remember that. Number four, the shear force V at any point X is equal to dm by dx, which is equal to EI d3V over dx3. Have you seen this expression before in your life? This one, I think you should have. In your statics course, I'm not sure whether you remember it. They used to teach you that V is equal to dm by dx. You used to make that bending moment diagram. Do you remember that? And when you used to take the derivative of it, that was your V. Does it ring bells? It does. In statics, they used to tell you. Then last but not least, a distributed load is equal to negative dV by dx, which is equal to negative EI d4V over dx power 4. Now, it's so much confusing, right? Nothing is confusing. Let me just jot down this for you. Number one, I want you to give me the deflection at every part of the beam. Number one. Number two, you have the following expressions. One is that deflection is a function of x. Two is that slope of that deflection, tan of theta, is nearly equal to theta is equal to dv by dx. Third expression is that moment at any section is equal to ei d square v over dx square, where E is the elastic modulus, I is the area moment of inertia of the cross section. V is the shear force at any section is equal to dm by dx is equal to ei, third derivative of the deflection with respect to x, and distributed load is equal to negative dv by dx is equal to this one. Now all of you, okay, I will wait for a couple of students who are writing. Now all of you are like, what should we do with these? Now I will tell you. It seems very complicated, right? What happened to my mobile? Yeah, hang on. It seems very complicated, right? It's not very complicated. Now I will start the actual question, and trust me, you will find this part of the course the easiest one. So please try to do this question along with me. You will really enjoy. So those expressions will be given to you, right? This is your cantilever beam. This is what I want from you today. Let me draw nice and beautiful cantilever beam. If somehow you can please do this question with me, trust me, it will save your time during exam preparation. So this is P. This length of the beam is L. I highly doubt you will be using any calculator, by the way. I think so. But anyways, this beam goes like this. Now, again, this is highly exaggerated. Now, the question says, I will tell you the question. Before I do that, I will just make a nice and beautiful cut. When I make the cut, what is the rule? The rule says that we will go down. Come on. The rule says that we will go down. And this will be like this. And this is your X starting from the left side. Now, all you have to do is do the summation of forces in the Y direction. I will tell you the question. I understand there are students who are saying, what is even the question? So I will have minus, let's say, minus, I think this is the load that is being applied here. So you can say, let's say, whatever directions you are comfortable with, let's say plus P plus V equal to 0. However, your instructors have taught you, B equal to, let's say, negative P. And similarly, before I tell you what is the question, anti-clockwise moment is positive. We will say plus Px plus Px plus M equal to 0, and M is equal to negative Px. Now we have students who are saying, what exactly are you trying to do? So let me just first rephrase the question. The question is that I want you to give me, find the deflection of the beam. Okay. This was the question, but before even I did the question, I just quickly went over this. So probably we can do this after we have started the question. Okay, first question for all of you. What is the number one step? The number one step is writing all those formulas. What was the formula? M bracket X is equal to, you can double check at your notes, EI, right? And then it was D square V over dx cube. So there are students who are saying, why did you write this formula? Well, you could have written the other formula as well. I wrote 4-5 formulas. Now the rest is easy, right? What is moment at any particular section? So first of all, you can define your x's. So this will be nice and beautiful. X is defined from the left. So I will have, let me just use a horizontal arrow, I think. I'm struggling with. Okay. So it will be minus px is equal to ei d square v over dx square. Then the next piece is, yeah, find the v. Do it. How would you do it? By the way, mask mandate is over, right? Okay, do it. I think I see a lot of students who are confused, so I will probably do a couple of more steps. Okay, how would I find the deflection? Well, my strategy will be that I will write ei d square v over dx square is equal to negative px. So d square v over dx square is equal to negative p over ei. Then we will have nice and beautiful x, and then I will have dv over dx is equal to negative p over ei x square over 2. What is v, by the way? Anyone? What is v? V is the deflection of the beam, right? So I will also add an integration constant, right? Hang on. I think I just want to be consistent with my notes. So I think in my notes, I did not take this on the right hand side, although it will not create too much of a difference. But I want to be consistent. I think that will make my life easy. Then I will have ei dv by dx is equal to minus p x square over 2 plus c1. Okay, now write v ei is equal to minus p x power 3 over 6 plus c1x, right? Anything else? Good. Thank you. Plus c2. And last but not least, the deflection will be equal to minus p x cube over 6 ei plus c1x over ei plus c2 over ei. Did you do it? You can do it with us. I think it will be a good practice, but again, it's your choice if you really want. If you're understanding, then that's fine. Okay, what was the question? You wanted to find the deflection of the beam, right? So my biggest question for all of you is, what are the C1 and C2? Anyone? C1 and C2? Okay, so V is a function of X, right? So you can from the beginning write bracket X if you really want. Bracket X, bracket X, bracket X, deflection function of X. So how can I find C1 and C2? Anyone? Okay, no one is responding. So that's why I will just tell you. I will use the boundary conditions. At x equal to L, what will be the deflection? Deflection is 0, right? Because at this point in the cantilever beam, there is no deflection. Any other boundary condition? At x equal to what? At x equal to L, I will have dv over dx, or tan theta nearly equal to theta is equal to 0, right? Sorry?
Why is the deflection equal to 0 when it's down?
Because cantilever beam at this point has 0 deflection.
But L is in the length of the whole beam.
Yeah, so x equal to 0 and x equal to L. So at this point, what is the deflection? 0. And what is the slope at this point? 0. It is horizontal, right? My x equal to 0 starts from left, by the way. So anyways, so give me the constants. Is it even clear? I thought it was easy. So what will be in the exam? In the exam, you should know that EI d square v by dx square is equal to the moment, let's say, and then you just start integration.
Yeah. C1 is PL square divided by 2.
Good. And C2? Okay, so I will just do it on the next slide. So what was the V? V bracket X is equal to negative P x cube over 6EI plus C1x over EI plus C2 over EI, right? Then V at L is equal to 0, which is equal to minus P L cube over 6EI plus C1L over EI plus C2 over EI is equal to 0, right? So this is your equation number A. And last but not least, you will say that dV by dx. Again, if you want to put a bracket x here, that deflection is a function of x, I don't have any issues, is equal to, take the derivative for me. What will be the derivative? It will be minus 3p x square over, so it will be minus p x square over 2EI, correct? Plus C1 over EI, and you have this at x equal to L is equal to, what is the boundary condition? 0. And you get minus PL square over 2EI plus C1 over EI is equal to 0. So this is your second equation. So what do you get? Give me the values. I mean,
PL square divided by 2.
C1 is equal to PL square divided by the way, how did everyone figure it out so quickly? Did you solve both of them? Nice. And C2?
minus PL cube divided by 3.
Again, very nice answer from one of the students. Very quick. Thank you. Okay. So what is the final expression? It will be V bracket X is equal to minus P over EI, correct? Then bracket, then follow with me. It will be, let's pull out the 6 as well. Again, it's entirely up to us. So it will be X cube, then minus, what will be 3 L square X plus 2L cube. Agreed or not? Can you please double check? So what I did is I put the C1 here, PL square over 2 whatever, and C2 here minus PL cube over 3 whatever. But I had already pulled out the 6. Can you double check? Ghazal, you are with us, right? Just take 2-3 minutes. I just pulled out. If you don't like me taking out the common, that's fine. You can just write in a simple way, minus px cube over 6 ei. True what? True. You double check. Okay. Instead of C1, substitute PL square over 2, and instead of C2, substitute minus PL cube over 3. Is it clear? Mitch? Sure. So what is the step that you will remember? At least for this question, you start from here, okay? Cram it, memorize it, whatever. And remember, V is the deflection. And the 4-5 more formulas that I showed you, you can also use them. But as of now, I think it's very easy. M equal to EI d square V by dx square, and you continue. Okay, do the next question for me. And by the way, you will do it. So the next question is, let's say I have simply supported beam. Okay, and the simply supported beam is, let's say, something like this. Oh, come on. You have to bear with me. Okay. And then I have like this. Okay. The next step is that you have nice and beautiful roller. Okay, do it. The question is that what I want from you is, okay, what is a realistic simply supported beam? A realistic simply supported beam will be like this, right? And why is that? Because the beam, it will have its own weight, right? And how its own weight will be acting? Of course, in this distributed fashion. So let me actually make this. By the way, all of you worked all of this in your statics, right? Yes? Okay, do the question. Okay, what is the question? The question says, that distributed load is W, the length of the beam is L, this is A, this is B. Okay, give me the deflection V. So if you want to find the deflection, what are the strategies? There are different strategies that you can follow. So let me show you the different strategies. Everyone, you can use equation number 3. You can use equation number 4. you can use equation number 5. You can see that equation 5 has distributed load as well written. So it entirely depends on you how you want to approach. If you ask me, I just love this equation number 3. Yes, Hussain and Mirch and Hamza. I personally, because prefer equation 3, I will just use this equation 3, let's say. So the number one thing is in equation 3, the moment, right? So I will say if I need moment, I will draw the free body diagram for a little section. So I make the cut. Okay, my X is defined from here. Okay, use the statics principles and give me the expression for moment. So you will find the reaction at A, you will find the reaction at B. Then you will find
what is the W?
distributed load.
Yeah, but what's the value?
No value. It's 1 kilo. It's 1 kilonewton per meter or whatever. It's per meter. So W multiplied by L is the weight of the beam. Okay, so just so that because I really want everyone to be with us, so I think I can help you a little bit. So number one thing is, what is the reaction here? It will be
X and Y.
it will be WL over 2. If it is WL by 2, then I will use the statics rules, and the statics rules tell me that this will be downward and I will have an anti-clockwise moment. So this is my V, and I can say, let's say, plus V if you want, minus WL by 2, and then I also have load acting from the top, which is let's say I'm cutting from a certain point here, so it will be WX. So let me put a WX here. I'm taking too much time, by the way. This is WX. So downward is positive, so I will write plus WX equal to 0, and I will be having V equal to WL by 2 minus WX. Similarly, what about your moment? So it will be anti-clockwise as positive. So you will have positive moment. Then you will have minus WL by 2 multiplied by X. And then you will have plus W. Yeah, I apologize. I think instead of writing here, I should have written here WX. I don't know, wherever you want to write. This is WX. As long as you know what you're doing. Okay, plus WX into X by 2, right? Equal to 0. So you will have M equal to WLX by 2 plus W x square over 2. Are you confused or are you with me? So I think there is a mistake, Wx by 2 minus Wx. Are you confused or is it fine? It is statics, right? No?
Then why did you change the position of that?
I don't know. It says Wx. You cut from any place and I have Wx. Why? There is no y for it. I think Wx, I just put it in the middle just for my own convenience. Because if I cut from here, so how much chunk will be here? There will be a Wx that I will have acting right in the middle. And I will have to do Wx into x by 2. That's why Wx into x by 2 comes into the picture. So I think when I am putting Wx in the middle makes more sense. Because at the end of the day, whatever Wx you're talking about, it acts at the center. Okay, is it clear? Yes, no? No? Okay. Now, if you have the moment, why don't you write that equation? What was that equation? Anyone who can please open the notes? M is equal to EI d square V over dx square. And what is V, by the way? V is the deflection of the beam. I'm repeating intentionally, so everyone understands that V is the deflection of the beam. Okay, now what do you want to do? Again, you want to put a bracket X just to emphasize that deflection is a function of X. And by the way, if I ask you how the deflection is happening, everyone will tell me this is how the beam is deflecting, correct? Anyone who doesn't agree with this? Okay. And probably you want to be a little more meticulous because the neutral axis is right at the center. Okay. And again, you have to be symmetrical, right? So make sure. Okay. Now that you have got this, why don't you integrate and tell me what will happen? It will be EI dV by dx is equal to WL x square over 4 minus x power 3 over 6. That's it. I think there will be a C1 as well because this is indefinite integral. Then the next piece is that you will say, and by the way, just remember that dV by dx is what? Tan theta, which is nearly equal to theta. Okay, last but not least, you can integrate everything one more time and you will get EI V equal to WL x power 3 over 12 minus W x power 4 over 24. Okay, what is V, by the way? What is the name of V? Deflection, exactly. I'm actually intentionally repeating for you because I know that you just arrived and I really want you to. C1x plus. Now, last but not least, you will just write, let me put a steric here, steric here, steric here. So now V is equal to WL x power 3 over 12 EI minus W x power 4 divided by 24 EI plus C1 x over EI and plus C2 over EI, correct? Okay, how can we find now C1 and C2? Boundary condition. Initial condition is technically not the right answer because initial condition means something that is dependent on time. Initial, the word initial means boundary conditions. So tell me the boundary conditions then. Okay, anyone who can tell us the boundary conditions? Say one more time. Deflection at
V is 0.
good. V at, very nice, thank you. V at x equal to 0. So just to be clear, what is my coordinate axis? This is my x, okay? So V at x equal to 0 is equal to 0 as one of the students told us. And the other boundary condition is V at x equal to L is equal to 0, right? Okay. So these are your boundary conditions. Give me C1 and C2 quickly. Give me C1 and C2. And in your head, you can always revise M equal to EI, D square V by dx square. X is the position.
So it's the variable that changes.
Of course. At X, for example, if I ask you, what is the deflection at X equal to L by 2? Then first you will derive the expression for D which you are, and then at the end you can write X equal to L by 2 will give me the deflection at V. No, I'm sorry, it will give me the deflection at X equal to L by 2. In fact, I should have emphasized it. X means the location at which you are trying to find the deflection. Once you have the expression, I ask you, what is the deflection of the beam at the center of the beam? Put x equal to L by 2. What is the deflection at 11 centimeters from the left side of the beam? You substitute 11 by 100 in your x. Okay, so C1 is, you tell me?
Minus WL divided by 12.
24.
12.
24 minus WL cube divided by 24 is in my notes. I can make a mistake, by the way. I can double check with you. Sure? Double check. Okay, unfortunately, I have to go to the next slide. So I will write V bracket X is equal to WL X power 3 over 12 EI minus W X power 4 over 24 EI plus C1 X over EI plus C2 over EI. And now boundary condition at X, V at X equal to 0 is equal to 0 and V at X equal to L is equal to 0. What is the constant? When you put X equal to 0, 0, 0, 0, 0, C2 will be 0 and C1 will be, let's say at X equal to L, it is 0. It will be WL L power 3 over 12 EI minus L power 4 over 24 EI plus C1L over EI plus C2 over. So I don't know. C2 is already 0. So C1 comes out to be minus WL power 3 over 24 Ti. Okay, I will now answer Mid's question. His question was very valid, by the way. What is X? So we will talk about Mid's question. V X is equal to. So just do number, just put everything there. So you put everything there, but I am also taking this out like this just for my own convenience. If you don't like it, it's entirely dependent on you. Minus X power 4 plus 2L X power 3 minus L power 3 X. What happened? Can I? Sure, positive. You can ask me. Okay. So I finally get this expression by pulling this out. Again, if you are uncomfortable in pulling this out, you can just substitute C1 here and C2 and write the whole thing. Now I will answer Mid's question. Why don't you give me the value of, why don't you tell me what is the deflection at X equal to L by 2. Anyone? Quickly do it. So this is your question. Huh? It is because of? It is better. Very good. So give me the chunk.
Just need to substitute values to in the last equation.
Huh, in the last, do it.
So, but it's not zero, right? Because of
Deflection? How can deflection be zero?
It's gonna be maximum.
Exactly. Deflection will be maximum. Okay. In fact, let me also answer Hussein's comment. How did he know that at X equal to L by 2, deflection is maximum? Number one, he knew this because you can even see just by observation. You have a distributed load like this. Oh, come on. Deflection will be maximum at the middle.
And that's also where maximum moment occurs, right? So if you just assume that as well, because that's the maximum.
Yeah, maximum moment also occurs, but I want to answer his question in a better way. Look, once you do this, you can tell me the value. You can also play this very little game. Take the first derivative of this deflection. In fact, you already have the, do you have the first derivative of deflection? I think you already have the first derivative of deflection, everyone, right? Why don't you do one thing for me? Why don't you please tell me what is dV by dx equal to 0? Give me the value of X. Anyone? Do it. Huh? Reeves can also help us. Just go to the previous slide where you already have dV by dx, or you can take the derivative here, which is pretty useless because why are you trying to find the derivative? Go back here. Just substitute, just do equal to 0. Give me the value of X. You already have C1, by the way. Nahin? Should I? Oh, what happened? Ek minute. Let me go back for you. Yeah, here. Substitute C1. Just give me this equal to 0 and give me the value of x in the form of L. So this is what I want. dv by dx equal to 0. Okay, this is a task for you, but I already know the answer. The x will come out to be L by 2 for sure. Why x will come out to be L by 2? Because the slope at L by 2 is 0. That's how one of the students figured out that the deflection is maximum at the middle. In a more complicated problem in which you have, let's say, a load acting at L by 3 or L by 5 at a random point, how would you know where the maximum deflection is happening? You will do the dv by dx, you will equate it to 0. That will tell you where the maximum deflection is happening, let's say. That may give you. So now v at x equal to L by 2. I'm not sure whether all of you got the expression. Anyways, you can put it here now. And you can make a remark here that this is V max. Because this gives you dv by dx, which is your tan theta nearly equal to theta. This implies that at x equal to L by 2, you have V max. So you will get x equal to L by 2. Okay. Okay. Did anyone found the expression at V equal to x, V at x equal to L by 2? No one? Anyways, we have only 2 minutes. Okay, last but not least, in the same problem, if I give you the value of elastic modulus as 29 into 10 power 3 kilo-pound per square inch, and I tell you that the beam is something like this. Let's say okay, and something like this, let's say. Again, you have to forgive me for the drawing. Something like this, I think. Whatever. And this is a W12 by 87, where this dimension is 12 and 87 means that the distributed load it is carrying is W pound by feet. Okay. So W12 by 87, and the moment of inertia of this section is about the neutral axis is 740 inch power 4. The length of the beam is 18 feet. Why don't you tell me what is V at x equal to L by 2? For the same one, for the same problem, this problem. Okay, so you do it yourself and you will have a answer. But no one actually even calculated the expression. Anyways, 87 by 12. I'm just writing the answer. You can double check in your free time. Into 10 power 3 into 1000. And I have minus 9 into 12 power 4 plus 2 into 18 into 12. Then I have a 9 into 12. I'm not even sure what is this. Anyways, minus 18 into 12 power 3 into 9 into 12. Just double check yourself. Again, I asked you to give me V at x equal to L by 2. You did not. You have to get the expression and then substitute the values. Anyways. Okay, everyone. Time for the dynamics class. Is this clear or not? Yes, no? Anyways. And another thing is that because this is a very symmetrical problem, although I already gave you two conditions, I didn't give you, you understood two conditions that at x equal to 0, x equal to L, at x equal to 0 and at x equal to L, you have V0. But there is one more thing. This is a symmetrical problem. So at x equal to L by 2, the slope will be 0, right?
Yes.
This can be used as a condition, but in this problem, I never used it as a condition. I just told you that you just find out at what value of x you will have maximum deflection. Then what we did is I asked you to equate dv by dx equal to 0 and yourself predict that, the answer comes out to be L by 2. This means I will have maximum slope at x equal to L by 2. Although by observation, you can also know that at x equal to L by 2, dv by dx is equal to 0. So this can be actually your, one more condition. We will call, we can call it as a, not a boundary condition, but kind of a continuity condition, if you want to call it. But yeah, kind of a condition.